Hi, this is meteorologist Steve Pelletieri, and I am the Weatherman. Welcome to our latest podcast. This time we're going to be talking about the upcoming severe weather season and tornado season. Well, actually, the tornado season, severe weather, is more likely during the months of March, April, and May. And when we take a look at the occurrences over these past few months, they have been high. They were actually high in March, which seems to be going down a bit. But now that we're getting into summertime, we're going to be looking at the air mass thunderstorms, cold fronts moving through. Seems to be that the atmosphere is in a little bit of a cooler trend, at least in the central and eastern section and the northeast. So something to consider right now is the severe weather, and of course what that may have to do also with the hurricane season that we're expecting to be above normal this year. We've always had severe storms and thunderstorms, even during the springtime when most severe weather occurs in the United States, as I mentioned. And that's because we have a combination of some very warm air starting to work its way north from the Gulf of Mexico, and a lot of cold air still over central Canada, working its way down south. Those strong cold fronts. And when the cold fronts meet the warm air, that's when all the trouble starts. That's basically how some of these severe storm areas form. In the summertime, it's just like we have the combination of not only frontal systems, but also air mass thunderstorms that form. There's a combination of much of the tropical weather that forms over the Gulf of Mexico into the Atlantic will also affect the eastern seaboard. And it can combine to make even more severe weather. Imagine having a hurricane along with tornadoes and thunderstorms, which are quite common in hurricanes and tropical systems as well. So we're going to be talking about severe weather and the hurricane season that's currently underway. Right now, this is how things look so far. Basically, in the last half of May, we had 4 tropical systems. One, Cristobal, that actually formed over the Yucatan Peninsula of Mexico and moved across the Gulf and went into Louisiana as a tropical storm, but gave them quite a bit of rainfall. So far, it's been quiet, though, as we go into the month of June, or at least middle to the second half of June. So that's something that we'll be looking for right now. We're also seeing a gigantic dust cloud working its way off the African coast. And this cloud you can see actually on a satellite photograph as of the 22nd of June. And it looks like this many times can dampen the development of hurricanes in that section of the world where we normally get the start of our Atlantic hurricanes. So that may keep the amounts down at least for the next several weeks. Now, when we think of severe weather, we think of thunderstorms and tornadoes. Most tornadoes form from thunderstorms, and you need warm, moist air from the Gulf of Mexico and cool, dry air from Canada in order to combine to make these storms. And when these two air masses meet, they create instability in the atmosphere. And very strong, violent tornadoes form when these areas of strong rotation develop as well. So the greater the difference between the air masses, the greater the likelihood that you're going to have a very strong thunderstorms and also tornadoes. Now, thunderstorms arise when layers of warm, moist air start to arrive in a swift updraft of cooler regions of the atmosphere. And because warm air is less dense, when it hits the colder air, it actually continues to rise even more so. And as it cools, because that's what's going to happen when the warm air rises, it cools, it actually causes condensing. The condensation makes clouds and also makes precipitation. Towering cumulus clouds are the ultimate of this rising motion that we see within the thundercloud or the thunderstorm cumulonimbus building, and they sometimes can get up to about 45 to 50,000 feet above the ground. So that could be also an indication of the strength of the storm as well. Now, when thunderstorms arise in layers of warm, moist air, and they move into those cooler regions of the atmosphere, the warm air is less dense, as mentioned, and it forms those clouds that we'll get into, and the combination of lines of these cumulonimbus clouds can cause squall lines. And of course, those squall lines can also contain locally severe weather and those straight line winds we were talking about that could get up to 125 miles per hour. Some of the straight line winds, along with frontal system lines and clusters of thunderstorms. We'll talk about these large and small hailstones also develop in these systems. And hailstones are quite interesting. A lot of folks confuse them with sleet during the wintertime. So it might be sleeting and they say it's hailing outside, but that basically it's not true. It's pretty much in the wintertime, everything you get is going to be in the form of what we call sleet or freezing rain or ice pellets, basically. That's more. Freezing rain is when it comes down as a liquid and hits the ground, and then it freezes over as the glaze. But ice pellets is sleet, and that's what we get during the wintertime. A lot of folks confuse that with hail. But most of the time, or not most of the time, all the time, your hail is going to come from thunderstorm activity. And that's why we have to look at thunderstorms, at least into the basics, to understand the processes that create hail. We call these thunderstorms because they're the result of lightning. It's lightning that produces thunder. Lightning rips through the atmosphere or right through the air and explodes the air molecules. And that net effect of the explosion of those air molecules causes, quite a bit of noise, especially when you have a very large or a long duration lightning strike that could be as much as a mile in length. And when that happens, of course, the explosion of those air molecules can be quite loud. And the closer it is to you, the louder the thunder, the closer the lightning is to you. And we'll get into that in just a moment. Now, lightning causes an average of 55 to 60 fatalities and about 400 injuries each and every year. And again, lightning forms with all thunderstorms, and it's going to be, a very costly thing, too. Lightning damage can cost up to $1 billion and insured losses every year in the United States. So I'm sure a lot of people, when considering the arrival of thunderstorms and lightning, they want to take note and also be well informed. Thunderstorms also cause those straight line winds I was telling you about. Some of these winds can exceed 125 miles per hour, but the difference between tornadoes and hurricanes and straight line winds is that, hurricanes, of course, are a very large scale system where the wind is basically coming in from one direction, but it seems as the storm gets into you, it starts to change. You're going to start changing the direction of that wind, but it's always very strong, and it gets stronger as you get close to the center. Tornadoes, very small footprint, but very strong winds. They go from as little as 65 miles per hour and what we call a force 0 or EF 0, up to EF 5, which is over 200 miles per hour. And we're going to get to that in a little while, but try to explain the enhanced Fujita scale as well. So that's something that we'll be talking about. But in the meantime, straight line winds can cause destruction equal to a tornado. And of course, I can imagine straight line winds are extremely dangerous to aviation interests. Like when you're on approach or getting ready to land and you encounter a straight line wind of 125 miles per hour, then that could be quite disastrous because the wind changes in intensity and it could even change in direction as well. So you're flying possibly with maybe a little bit of a quartering wind and maybe about 40 knots on approach, and then all of a sudden 125 miles an hour comes from behind you or from your side. Makes tremendous turbulence and also can many times cause misapproaches and unfortunately mishaps as well. Straight line winds, very bad. Thunderstorms also cause flash flooding and floods, and they are the number one cause of deaths associated with thunderstorms. Flooding, not lightning, causes the number one reason for deaths associated with thunderstorms. Flooding and flash flooding cause more than 90 fatalities each year from severe thunderstorms, and you can get tornadoes from those severe thunderstorms, and they cause an average of 60 to 65 fatalities every year, over 1,500 injuries with both. So tornadoes are categorized from what we call force 0, and I mentioned that earlier, to about force 5, and it's the extended Fujita, enhanced Fujita scale, 0 to enhanced Fujita scale 5. And that's the ones that can exceed 200 miles per hour. Now, tornadoes don't have to be necessarily small. They could be as much as a mile wide. And they can stay on the ground and travel for over 50 miles. Also, some tornadoes are very small, maybe only about an acre or less, or possibly only a couple of hundred feet in diameter. But again, many times these tornadoes will move and then bounce off the ground, come right back down again in another place. It all depends on the atmospheric dynamics that are above the tornado. And of course, hail is a big factor, a big product of thunderstorms and the thunderhead. Some of these hailstones can be larger than softballs, more than 5 inches in diameter. But any size hail can cause a lot of damage. More than $1 billion in crop and property damage each and every year from hail. Now let's break away for a minute and just talk about hail and hailstones. Hail is a form of precipitation consisting of solid ice that forms inside thunderstorm updrafts. Hail can damage aircrafts, homes, and cars, and can be deadly to livestock, also crops, and of course people. Hailstorms are formed when raindrops are carried upward by the thunderstorm updraft into extremely cold areas of the atmosphere. And that's where the big raindrop freezes. Hailstones grow by colliding with liquid water drops that freeze into the hailstone surface, especially as they start to fall back again and get caught back into an updraft. So in a thunderhead, you're going to have sections that temperatures within the thunderhead are Below freezing, that's where the hailstone freezes, and above freezing, that's when it falls, picks up regular moisture, gets caught in an updraft, goes back up, and then refreezes again there. Now, when you see a hailstone, sometimes you'll see they're clear, and sometimes you'll see that they are sort of clouded, or you can't see right through them, sort of a opaque type of ice situation. And that's when bubbles form inside of the hailstone. So that, again, has something to do with the character of the thunderhead column. Now, this cloudy ice will form as air bubbles will be trapped in the newly formed ice as it travels higher into the thunder column. However, if the water freezes slowly, the air bubbles can escape and the new ice will be clear. So we have the possibility of cloudy or clear hailstones, and hailstones fall when a thunderstorm updraft can no longer support the weight of the hailstone, which could occur if the stone becomes large enough or if the updraft weakens, the updraft within the column. If that weakens, hailstone will start to fall out as well. And on its way down, especially as it gets into the warmer sector of the thunderhead, sometimes they melt, and that's why many times we'll have those very large drops that are associated with thunderstorms. And a lot of times there were hailstones, and they basically just melted on the way down because of the warmer temperatures in the lower portion of the thunderhead. So with all that in mind, hail falls when it becomes heavy enough to overcome the strength of the thunderstorm updraft, or just becomes too heavy and is pulled towards the earth by gravity. Smaller hailstones can be blown away from the updraft by horizontal winds. Remember, a thunderstorm is usually moving in a specific direction, many times between 20 to 40 miles per hour, sometimes even 50 miles per hour. So there's a vertical speed, and then there's a horizontal speed within a thunderstorm. Whenever you have some of that wind-driven hail, it can tear up the siding of houses, break windows and cars and houses as well, and blow into houses after the windows break, and you'll have a tremendous amount of hailstones, or at least small pea-sized hailstones within your house. It can also cause tremendous denting of cars. The denting of cars, of course, is obvious with the golf ball size or softball size hail falling on a car. It's just going to dent. It's going to break windows and do a lot of damage. But even those smaller hailstones that are moving in a vertical direction, or at least a somewhat vertical direction, are going faster. So they also cause quite a bit of damage as well. With that in mind, you might wonder just how fast the hailstones fall from a cloud. Unfortunately, the answer is complicated. The fall speed of hailstones primarily depends on the size of the hailstone, the friction between the hailstone and the surrounding air, local wind conditions, both horizontal and vertical, and the degree of melting of the hailstone as it falls as well. Now, some researchers assume that the hailstone falls like solid ice spheres and shows some very high fall speeds for small hailstones. This assumed fall speed, however, is between 9 and 25 miles per hour. For sure, hailstones that one would typically see in a severe thunderstorm are from about as much as a pea to about maybe as much as an inch or so. Some places even 2 inches out in the Midwest. And you would typically expect some faster fall speeds when the hailstones get a little bit larger. So those that are about 1 to 2 inches, the fall speed is between 25 and 40 miles per hour. And it gets worse, of course, in what we call supercells. These yield the largest hailstones of the 2 to 5 inch diameter. And the fall speed of the largest hailstones is between 44 and 72 miles per hour. But again, these are just estimates. More research is being done on hail from thunderstorms each and every day. But just keep in mind, if you had something between 4 to 6 inch hailstones falling at 72 miles per hour, that's like a solid baseball or grapefruit falling that fast. It does quite a bit of damage. And not only the damage to property, but also to crops and to livestock as well. So it's a big thing to consider out in the Midwest. What areas of the country have the most hail? Well, although Florida has the most thunderstorms, it's Nebraska, Colorado, Wyoming. They usually have the most hailstorms, those 3 states. The area where these 3 states meet is called Hail Alley, and they average between 7 and 9 hail days per year. But these heavy hail areas are not restricted to just the United States or North America. You can look to China, Russia, India, and northern Italy, and those places also receive quite a bit of hail. But for us, if we see a hailstone, we notice hail, we can help the community by describing the weather event to our local officials or to the National Weather Service or even to our insurance companies if necessary, especially if they've done quite a bit of damage to our property. Simply, if you want to categorize it in a very simple way, you just look at the size and sort of make it an example of some common object. For example, pea-sized hail is about a 1/4 inch diameter. Penny-sized hail is about 3/4 of an inch diameter. You can say a 1/4 to 1 inch, that could be marble-sized. A 1 3/4 inches hail is a ping pong ball or golf ball sized. Up to 3-inch diameter, baseball size. And of course, the big one, grapefruit-sized hail, about 4 inches plus. And we don't want to see that. Getting back to thunderstorms, a thunderstorm affects a relatively small area. I mentioned that earlier, as compared to the hurricane or winter storm or any type of storm for that matter. The typical thunderstorm is 15 miles in diameter and only lasts for up to an average of 30 minutes. Despite their small size, all thunderstorms are dangerous. Of the estimated 100,000 thunderstorms that occur each year in the United States alone, about 10% are classified as severe. In order for a thunderstorm to form, we need the 3 basic ingredients: moisture to make the form of the clouds and the rain and the unstable air, warm air that can rise rapidly, and third, lift. This is caused by the cold or warm front, sea breezes, mountains, or just basically the sun's heat when considering what we call air mass thunderstorms. Thunderstorms have 3 stages, like a life cycle. The first is the developing stage. That's when you see the towering cumulus clouds. A little bit of rain can come from that. It lasts for about 10 minutes for that developing stage. And even with these towering cumulus clouds, you can also get occasional lightning. The second stage is the mature stage. And this is the most likely time for hail, heavy rain, frequent lightning, and strong winds, and even the possibility of tornadoes. Visually, the storms occasionally have a black or a dark green appearance when they're in the mature stage. So you see one of those coming towards you, you know it's time to take shelter. This phase, the mature phase, usually lasts on average only 10 to 20 minutes, but some of these storms could last a lot longer. The third and final stage of a thunderstorm is the dissipation stage. Now, remember, we're talking about up and downdrafts within a mature thunderstorm, the mature stage, that second stage. But when the dissipation stage takes hold, all the action is downward. Downward flowing air usually causes evaporation, and it dominates the storm as it's dying. As it continues to decrease in intensity, of course, rainfall will decrease in intensity as well. You can still cause strong bursts of winds because as we have descending motion and as you have evaporation, in other words, going from a water vapor or a cloud droplet or even rainfall, as it dries out, it cools. That cooling motion will actually cause the air to become heavier, so it starts to fall, the actual air starts to fall a little bit heavier. And as it gets close to the ground, hits that ground and then goes forward in the direction of the storm. So you can have those quick bursts of wind even as the thunderstorm is diminishing. Now, thunderstorms can also produce severe storms, which include hail, as we mentioned, strong damaging straight-line winds, and also the possibility of tornadoes. Although tornadoes occur in many parts of the world, they're found most frequently in the United States, from the whole world, most frequently right here in the United States. On an average year, we can get 1,200 tornadoes, 1,200 tornadoes. They result in about 60 to 65 fatalities and 1,500 injuries nationwide. Factually, a tornado is a violently rotating column of air extending from cumuliform clouds, such as a thunderstorm, right to the ground. In their developing stages, they appear to be what's called roll clouds, and they swing down from the base of the cloud, sort of like a door swimming on a horizontal, going vertical. Tornadoes may appear transparent until dust and debris are picked up or a cloud forms within the funnel. The average tornado moves from the southwest to the northeast, but tornadoes really can move in any direction and can suddenly change the direction of motion as well. Now, an average forward speed of a tornado is 30 miles per hour, but it could vary from a stationary tornado to as much as 70 miles per hour in forward speed. The strongest tornadoes have rotating winds of more than 200 miles per hour, and tornadoes can accompany tropical storms and hurricanes as they move onto land, as I mentioned, and also waterspouts. Waterspouts are simply tornadoes that form over water, but waterspouts can move onshore and cause damage to coastal areas. Be prepared. You have to be ready for the possibility of tornadoes year-round, as they can happen any time of day, any day of the year, especially in places prone for tornadoes. You have to have a plan of action. We talked about this in a previous podcast before. When severe weather threatens, you don't want to try to figure out what to do and how to stay safe when that storm is moving right towards you. You need to respond quickly when a warning is issued or a tornado is spotted. When conditions are warm, humid, and windy, or skies are threatening, monitor for severe weather watches and warnings by listening to NOAA Weather Radio, logging into weather.gov, or tuning to your nearby radio or television station. You can also obtain text alerts on your phone from many sources and weather companies, like my company, Ion Weather Research. Earlier, I told you about the scale of tornadoes. Well, our scale that we use is from the great tornado and severe storms researcher, Dr. Ted Fujita. Ted was a prominent Japanese-American storms researcher that developed the first Fujita scale of tornadoes back in 1965. Now, we're going to talk about Dr. Fujita and his work in future podcasts. But Dr. Fujita's F scale was improved during the early 2000s by a team of meteorologists and wind engineers who developed the enhanced Fujita scale, or EF scale. The scale was adopted by the National Weather Service in 2007 and is in use today. Again, the enhanced or EF scale is used to assign a ranking of tornadoes based on estimated wind speeds and related damage. So here's how the EF scale goes. When we talk about wind speeds, we're talking about 3-second wind gusts. But for the most part, they represent a constant, very strong wind in tornadoes. An EF0 tornado is a 3-second wind gust of 65 to 85 miles per hour. And that is the lightest of all tornadoes. And many times you do see those on the eastern seaboard or in the northeast. We have a lot of them in New Jersey, eastern PA, southern New York. Those are EF0s. Also, sometimes an EF1. Now, EF1 is from 86 to 110 miles per hour. The EF2, of course, a little bit stronger, 111 to 135 miles per hour. And then we start to get into some serious Midwestern type of tornadoes that you see in pictures and that you hear about. EF3s, 136 to 165 miles per hour. It gets even worse. An EF4 is from 166 miles per hour to 200 miles per hour. That's an amazing amount of wind in just these very tight areas that tornadoes can be in. And the granddaddy of them all, you don't want to see this or be around when it's here, an EF5. And that's when winds are estimated to be over 200 miles per hour. Surely, an EF5 tornado results in the most catastrophic damage. I'd like to talk about the 10% of all thunderstorms that produce severe weather. Now, the risk criteria by the National Weather Service for severe thunderstorms or severe weather refers to a thunderstorm that is either producing hail, and some of that hail has to be at least 1 inch in diameter or larger, and wind gusts of 58 miles per hour or greater, or even a tornado. So any one of those 4 factors and you've got severe weather, and it will be classified as such. Although lightning can be deadly, that brings us to a little discussion about lightning. Now, lightning is a giant spark of electricity in the atmosphere, usually between clouds and the air or the ground. In early stages of development, air acts as an insulator between the positive and negative charges on the ground or between 2 clouds or from the ground to a cloud. The opposite charges build up enough, this insulating capacity of the air breaks down, and there's a rapid discharge of electricity. And that's what we call, and what we know as, lightning. The flash of lightning temporarily equalizes the charged regions of the atmosphere until the opposite charges, positive and negative, build up again. So basically what's happening is supercharged positive and negative buildup between 2 places, either cloud to cloud or cloud to ground. They connect, discharge, equalize, and then it's over, and the whole process repeats itself, all in a flickering flash of a second or so. Lightning is one of the oldest observed natural phenomena on Earth. It can be seen in volcanic eruptions, extremely intense forest fires, surface nuclear detonations, heavy snowstorms, and of course, in large hurricanes, and obviously in thunderstorms. The result of lightning is thunder. Energy from lightning channels to heat the air briefly to about 50,000 degrees Fahrenheit. That's much hotter than the surface of the sun that we spoke about in the last podcast. This causes the air to explode outward. The huge pressure in the initial outward shock wave decreases rapidly with the increased distance, and within 10 yards from the lightning strike, sound produced is what we call thunder. Light from the lightning travels through the air roughly 1 million times faster than sound does. 1 million times faster. Now, because of this fact, you can use thunder to estimate the distance to the lightning that you saw. Simply count the number of seconds from the time you see the flash until you hear the thunder. Lightning travels at possibly about a fifth of a mile per second, and that's 1/3 of a kilometer per second. So dividing the number of seconds by 5, the result will be the number of miles to the flash. For example, you see the flash, you hear the thunder in 10 seconds, 10 divided by 5 is 2 miles away. Where does lightning strike most? Generally, not all lightning flashes that we have produced by a storm start inside the cloud. When lightning flashes go in to strike the ground, a channel develops from the cloud downward towards the surface. Now, when it gets to roughly 100 yards off the ground, about 300 feet up, objects like trees, bushes, and buildings start sending up sparks to meet it. Most folks don't know that. Lightning comes down from the cloud to about 100 yards from the surface, and lightning strikes move up from the ground or up from the thing about to get hit towards the bolt. They meet and complete the circuit. Thunder is produced. Also, that flickering you see is actually many lightning strikes in a fraction of a second. Tall objects like trees and skyscrapers are more likely than the surrounding ground to produce one of the connecting sparks, as they're cold. A little bit higher, of course, and those sparks can generate very quickly, more readily from those places. So that means higher objects are more likely to be struck than low surface objects. Mountains make good targets. However, this does not mean that high objects are the only targets for lightning. Lightning can strike the ground in an open field, even if the tree line is close by. So there you have it. Severe thunderstorms, straight-line winds, tornadoes, lightning, thunder, and of course the flash flooding, all a part of something you should be aware of when warned, and be aware of by visually looking and observing in your outdoor elements. One of the ways you know you're going to have a severe storm or a heavy downpour for that matter is to know some basics. For example, let's imagine it's a sunny, warm, humid day, and the winds are light. You notice darkness to the west, southwest, or to the northwest. Along with that darkness, you may hear rumbles of thunder in the distance. And an instantaneous wind could increase rapidly over 20 miles per hour. Sometimes severe straight-line winds occur before thunderstorms hit. This is an indication to you that heavy rain is falling or even hail underneath the thunderstorm. The rain and the massive hail fall to the ground, displace the air, and move it forward in the direction that the thunderstorm is moving. So if the winds pick up where you are, it's moving towards you in that way. Probably right towards your location, especially if the winds are very, very strong. Listen to the news, check your phone for alerts, check online for alerts and warnings, and listen to NOAA Weather Radio to get the latest information to stay safe. As mentioned earlier, severe thunderstorms could occur at any time, usually in the late afternoon and evening, but again, can occur at just about any time, even during the overnight. As for the peak time of year is concerned, it's usually during the spring months of March, April, and May, that we're finally leaving. But in the east, this past March, April, and May were a little on the cool side. So with this in mind, it's a good possibility that some of the severe weather could extend into those early summer months. So be warned. Stay aware, and as always, stay safe. Just an update on the 2020 Atlantic hurricane season so far into late June. And of course, as mentioned earlier, we had tropical storms formed during the last half of May. We had Tropical Storm Arthur, Tropical Storm Bertha, and just towards the end of May, early June, Tropical Storm Cristobal, which actually formed over the Yucatan and moved across the Gulf of Mexico, caused lots of rain across Louisiana, East Texas, and sections of Alabama and Mississippi. The storm continued up the Mississippi River Valley and got absorbed there. And our other storms that have been looking at, but so far in late June seems to be that everything is on the light side. And I also mentioned that dust cloud that seems to be coming off the Sahara, moving into the south central Atlantic, and that may hold back some tropical development for a while, at least off into the Atlantic. You'll probably have something form in the Gulf of Mexico a little bit more readily, but that cloud is expected to reach the southern portion of the United States and Mexico, at least aloft, and that will probably happen over the next several days. I'd like to say a few words about what the National Hurricane Center is doing to constantly upgrade and improve their forecasting and analysis. The various hurricane centers and typhoon warning centers throughout the world are initiating analysis of what's called invests. This Invest Now and is an investigation in an area of disturbed weather for which the National Hurricane Center is interested in collecting special data. Some of that data includes microwave, satellite, and specific model guidance. While the National Hurricane Center says that designating a disturbance as an invest does not correspond to any particular likelihood that's going to develop into, say, a tropical cyclone, a tropical storm, or a hurricane. An invest probably won't do that, but it does have some pretty good information there that they want to use. And it's generally known that if the National Hurricane Center designates an invest, that the system is of interest to them. Usually the National Hurricane Center has at least a low chance of projecting Invest to be a subtropical system, as I mentioned. And all the information gathered about Invest is put into a data system and used for other analysis as well throughout the year and other type of storms that form. We had Invest called 94L. That was what it was called during the week of June 15th through 19th, right off the North Carolina and South Carolina coast. Eventually, that storm moved overland. Invest are not limited to the Atlantic, but they also are being plotted in the Eastern and Central Pacific as well. And again, they're not the names that you hear from like the Weather Channel. They name them. They name just about any storm, especially in the wintertime. Invest are basically named by the National Hurricane Center, and they have to name in order they can archive that information. Hey, 94L did this. This is the data that we have. So this way you have a tracking method that's easier to understand. So in closing, I'd like to at least give you the information from the National Storm Prediction Center saying what's to expect this upcoming summer as far as severe weather is concerned. The Storm Prediction Center, called the SPC, maintains a high-achieving staff using innovative science and technology to deliver timely and accurate watch and forecast products dealing with tornadoes and, of course, severe storms, also dealing with lightning, wildfires. Not much of a big problem here in the East, but out in the West, wildfires are a terrible problem, and they're always on top of that. And this is for the whole United States and North America, all meant to protect lives and property. The Storm Prediction Center is part of the National Weather Service, and it's also the National Centers of Environmental Prediction. That organization that knows most of the model work that has been so ingrained in forecasting techniques. The Center for Model Work is at College Park in Maryland. The Storm Prediction Center is located in Norman, Oklahoma, and they were a valuable asset to the safety considering the fierce storms and any storms that move across North America and our nation. So if you're interested in Storm Prediction Center, and as I mentioned, it's in Norman, Oklahoma, there are also the National Severe Storms Laboratory at the University of Oklahoma School of Meteorology. So if you're a youngster and you're planning to go to school for meteorology, there's a place that you can get some tremendous information. Of course, there's loads of schools across the nation, and we'll talk about that in the future as well. There are other members of the National Weather Center do provide more specific opportunities and discoveries. You can get involved by contacting them in Norman, Oklahoma, the SPC. At their address is SPC, and it's SPC at NOAA.gov. That's SPC feedback, FEEDBACK, at NOAA.gov, and they'll give you good information there. As far as what to expect for this upcoming summer season and into early fall and September, I can tell you that the data shows that April was the most active as far as severe storms were concerned. Then April, a little less so, and also in May, a little bit less. But in early June of this year, showed an increase in severe storms, but that seems to have diminished just a bit as we go towards the latter half or the end of the month of June and into early July. The months of July and August are usually associated with air mass thunderstorms, as cold fronts very rarely get too far south. Severe storms predictions only needs marginal amounts of differences in the masses across the nation's Great Plains. So quite often, cold, hot boundaries spark severe weather in those places. So it looks like more of a normal pattern this upcoming summer, as the temperature trends have been at or below normal. That trend may continue into the summertime. The result, a more minimum of severe storm occurrences, but tropical systems that affect the Gulf and the eastern seaboard or Florida will increase severe storm occurrences in those areas. And if we're yielding to the fact that the National Hurricane Center that we're going to have a 70% chance of above normal hurricane activity and 23% chance of normal hurricane activity, that's a total of a 93% probability that we're going to have above or at least normal hurricane activity in the Atlantic this upcoming season. So it bodes well that tropical cyclones will most likely be a major contributor to the development of severe storms in the nation this summer. Well, there you have it, a lot of detailed information on thunderstorms and severe weather. I really hope you can appreciate and respect our wonderful National Weather Service organization that is so coordinated through many specialized weather centers just to keep us safe from the environment. And it does a great job, I believe, alerting and warning us to upcoming weather events that could be natural disasters. I'll do a podcast on the National Weather Service and their various centers. Well, that'll be for another time. I want to thank you for listening to this podcast on severe weather and the hurricane season update. Next time, I'm going to be talking about aviation weather and some of the tips on summer flying weather and some of the services that are available to you. And if in fact you are a pilot or if you have an interest in aviation weather briefings, I think you'll find the next podcast very interesting. I'm certified consultant meteorologist Steve Pelletieri, and I am the Weatherman. Thanks for listening. Talk to you next time.